All right, so lads and ladies, let's get started with this question from last year's back. Now, this is a question which involves a bit of calculus and a bit of applications. Two words which I imagine have you all running for the hills. But don't worry, we're going to break it down. We'll make it fully manageable. So I'm talking here about the velocity of a moving object. It's given by a function little f. I'm not actually given little f. What I'm given is a primitive of f, capital F, and here it is right here. So here's my capital F, and there we go. It's 2/3 t cubed plus 3t. Okay, so that's my primitive of F. And then we're told times expressed in seconds, capital F of t is expressed in meters. Grand job. Part A, they're asking me to determine an expression for F of t, the velocity in meters per second. All right. And B, the displacement in meters of the moving object between t is equal to A and t is equal to B is given by the integral from bounds A and B of f of t dt. And I'm asked to calculate the displacement of the moving object between t is equal to 0 and t is equal to 3. Now, for now, I'm just going to cut out some of the noise. I'm just going to get rid of part B there and just leave us with part A for the minute. Now, look, even if I didn't understand the question, one of the first things that I'm going to look at is they've asked me there now for sorry, just having a problem with that. There we go, we're sorted. They've asked me for f of t, and I'm told that I was given this primitive. So even if I don't know what's going on in the question, I know that I'm just going to have to differentiate. I'm given a primitive. If I want to go from primitive to function, I'm differentiating since the primitive is the integral of the function, if you know what I mean. But sort of getting a little bit deeper on this question, right? We're dealing with velocity. Velocity is all about movement, okay? So we got the three stages of movement which are linked together. We've got displacement, all right? Then we've got velocity or speed, velocity, okay, or speed. Right? And then we go down to acceleration. Now, what links all of these things? Acceleration. What links all of these things is what we call a rate of change. So displacement is me moving, or an object, should I say, moving from one place to another. Okay. And if I look at the rate of change of movement, all right, then I'm looking at the speed. How fast do I move from one place to the other? That would be a rate of change. Okay, and as soon as I see the word rate or the words rate of change or the concept of a rate of change, I'm automatically thinking about differentiate. Differentiate. Right. So rate of change and differentiate, it always means that. Now, like I say, displacement to velocity. Velocity is what is the rate of change of my displacement? That's what we call speed or velocity. And if I look at acceleration, what does acceleration mean? It is a rate of change of speed. How quickly is my speed changing? If I'm accelerating hard, it means that my speed is changing quickly. If I'm accelerating softly, or even if I'm decelerating, it would mean that my velocity was diminishing or going down. Okay, so again, each of these, so velocity is a rate of change of displacement, acceleration, a rate of change of speed. And wherever I see rate of change, I know that I am differentiating. In the same way that I differentiate going in one direction, so if down here I'm going to differentiate from displacement to speed, I'm going to differentiate from speed to acceleration, I would integrate going backwards from velocity to displacement, etc. Okay, so keep that concept in the head. Like I said, even without that concept, look, I've been given a whole pile of information and I'm told that f of t is an integral of, capital F of t is a primitive or an integral of little f of t. And here I'm looking for little f of t. Okay. And little f of t is going to be equal to capital F prime of t, right? So the derivative of f of t, capital F of t. And so when I do that, when I get the derivative capital F of t, I'm going to get, this is a simple differentiation, 3 times 2 over 3. So we get 3 times 2 over 3 t, and we diminish the power by 1, so it's t squared plus 3. Okay, t is going to go to t to the 0. Now my 3's cancel off there, and I'm left with that function being 2 t squared plus 3. Now, would you believe it? I've actually already finished off part A. There is nothing more to be done there, only to leave it like that. That is part A, done and dusted. Now, I would always say, good idea to go back to the question and just make absolutely sure that I have answered the question. All right. So what did part A ask me to determine an expression? So that's an expression, okay, for f of t, the velocity in meters per second, okay? And so this was f of t. I said that little f of t was equal to capital F of t prime, all right? And then I differentiated to find out what capital F of t prime would be. So there you go. That would be my f of t in meters per second. Great. That's my part A done, right? Now, what I'm going to do at this stage actually is I'm going to copy down my function, okay? I'm going to copy my function. That's 2 over 3t cubed plus 3t, right? And we're just going to do a little bit of messing around here. 2 over 3t cubed plus 3t, because we need to get our part B out. All right. But I thought to kind of get rid of most of part A because we don't really use it. Well, would I do that? Yeah, I would. 2 over 3t cubed. Now, here we go. What did we say it was? Capital F of t was equal to 2 over 3t cubed plus, what was it? 3t it was. There you go. Okay. Now, let's have a look at this second part of it. So, okay, now this time we're being asked for the displacement, all right? Now we said this before, that if f of t, they gave us f of t and they told us that was the velocity, okay? And so we know that what we're looking for here is we're looking for actually the primitive. F of t is going to be the displacement. When I see displacement, I know that it is the primitive in relation to the velocity, okay? So I know that I'm looking for my primitive. Well, isn't that great, right? They said even, they gave it to you here again. They said the integral of little f of t. And sure, I know, look here, I'm going to give you a formula. This one's available on your formula books, right? There it is. You even have this written down for yourself. Look at, you have from A to B of little f of x dx is equal to capital F of B minus capital F of A. Look, it couldn't actually be easier, all right? Because we know we have our capital F of T here, right? We copied it down from before. That was given to us in the question, and we're looking from that from A to B. So I know if I'll copy down the question now, the integral from A to B, and we said T is equal to 0 and T is equal to 3, so I'm going to use 0 and 3 for my A and B there, of f of t dt, that's going to be equal to, right, capital F of 3 minus capital F of 0. Literally that easy. This question is a 6-mark question, and so far the language was hard, but the question itself is kind of fairly straightforward, all right? So let's have a look at that then. Capital F of 3 would be, look, I'm just going to write my equals here. Capital F of 3, that would be 2 over 3 cubed. All right, I'm filling in 3 instead of t from my capital F of t, plus 3 times, still filling in 3 for t, 3 times 3 there, minus, and I'm going to open a big bracket here because we're minusing capital F of 0, all right? I'm on to this part of it here now. Oh, no, we're on to this part of it here. All right. So filling in that bit. So I open up my full brackets to know that I'm minusing everything in that brackets. Anyways, there's going to be nothing at all in the brackets. Don't worry. It is 2 over 3. I have the wrong pen. Would you stop? No. Let's get back to my proper pen. 2. Now 2 over 3 times 0 cubed plus 3 times 0. Now, 0 cubed is 0. 2 over 3 times 0 is 0. Plus 3 times 0. All of this in here is just equal to 0. So I'm effectively doing minus 0. Minus 0 doesn't change the result at all. So I can ignore that completely. Let's have a look at the next bit here. Then we had 2 over 3 times 3 cubed. 3 cubed is going to be 3 times 3 is 9. 9 times 3, 27. So we'd have 2 times 27 divided by 3 plus 3 times 3 is 9. Okay. Now, you could as well, if you wanted to early on here, you could have cancelled your 3 underneath the line here with one of your 3's up here, that making it 3 squared. That would be 2 times 9, which is equal to 18 plus 9, which is going to give me 27. That's one way of going about it. Otherwise, we have our 2 times 27 is 54. 54 divided by 3 is still going to give me 18. All right, so finally, here we go. Now, you were asked, so at this point in time, I think, grand job, I've answered my question. I'm too cool for school, right? But I'm always going to go back and I'm always going to check and make sure I've actually answered the question. Calculate the displacement of the moving object between t is equal to 0 and t is equal to 3. Have I done that? They told me displacement was given by the integral. I calculated my integral from a to b. The last thing there is I was asked to calculate a displacement. Now, a displacement is how much you've moved. All right. So lastly and finally, I'm just going to fill in 27 meters. Okay. So, and if I really want to go gold star answer on this question, I'm going to go the displacement. Now, to be honest with you, I'd have probably given you full marks already if you'd have put in your 27 meters. If you hadn't have put in your meters, if there was no meters there, I'd probably take a wee mark off you all the same. The displacement in the first 3 seconds, this is really, like I said, this is just to make sure that you show the examiner that you know exactly what's going on in this question, right? The displacement in the first 3 seconds from t is equal to 0 to t is equal to 3 is the first 3 seconds. Is 27 meters. Now, that is literally, like I say, that's just making absolutely certain that I show the examiner that I am the bomb, that I know super well exactly what's going on throughout this question. That is gold starring the answer. That's making sure that I get 6 full marks out of it. As I say, if you'd have stopped here, if you'd have stopped with the 27 meters, you'd have likely got full marks anyways. And if you'd have forgotten your meters, you might have lost a mark. All right, so as usual, I hope you enjoyed the video. If you got something out of it, send it out to your friends, right? Everybody needs to be practicing as much maths as they can during these Easter holidays to make sure that you get the most out of your revision for your bac. All right, send it on to your friends, send it on to your WhatsApp groups so that everybody can have access to it, right? I'll be uploading another one in a couple of days. So drop us a like, drop us a follow if you want. And remember, if you're really enjoying the videos, we will be running a revision course starting on the 12th of May. Check it out on our website. On our website. The link is in the description. Thanks very much, guys. Talk to you later.